Hey folks, and welcome back to API Can Code's Unit 3, particularly Lesson 3.6, where students are going to explore linear models with Story Builder built into CodeApp. So first, to warm up, we're looking today at a graph to the right of derailed train cars from 1975 to 2022. You'll see some interesting patterns emerge. For one thing, you can actually track train routes across the US with this map because there can't be a derailed train car where there is no rail line. The other thing is you'll notice some areas where derails are pretty common. For example, around Chicago, you see a pretty big circle. So you could point out these trends to students, think about the story it portrays, think about where these accidents happen and why students think that might be true. So next we're going to recap lesson 3.5. In the last lesson we used CodeApp to create confidence intervals, building more robust estimates for population means, or helping us see if there was a difference between two populations. And last lesson we did use that Zillow data. Today we're going to be using more real data, this time drawn about earthquakes. So there's a quick video here that you can and probably should play for students on recent and historic earthquakes by energy release, getting them used to this Richter scale a little bit. As we move in, we're going to grab some data from the US Geological Survey. There's a link to the website in this slide. We are looking for the past day all earthquakes dataset. This one is large enough and has some interesting variety to it without being totally overwhelming. If you go to, say, all earthquakes in the past week or month, it winds up being such a huge data set that sometimes it crashes some of our programs, so please don't do that. We tried to emphasize two things here. First of all, geologists might use data like this to study trends in earthquakes. Again, we're trying to expand this idea of who is a data scientist to include geologists. Secondly, we want to emphasize that this is a really good source of data. It comes from the US Geological Survey, which obviously is a pretty expert agency in this area. It does not come from something like a WordPress blog. So we really want to emphasize to students this is a great sort of truthful data set that we could trust. There's also some other factors we can consider, like how many earthquakes are cataloged. There's potentially a lot in some of the larger data sets, and the fact that it's updated very frequently, I think every minute. So we're going to do a couple things to get this over to CodeApp. First of all, we're going to convert this CSV file, which we've downloaded at this point, to a JSON. So we're going to go to the CSV converter, drop the file in, get headers, and please keep all the headers selected, so you should be able to click the Select All button, and then convert selected columns to JSON. At that point, you should be able to copy that JSON at the bottom and move over to EduBox. In EduBox, we've got a program ready to go for you. It's going to take in that JSON that students just created from our converter program. It's going to grab a couple key pieces of information. These are location, time, depth, magnitude, latitude, and longitude. There's something a little bit weird about this code that you might notice, which is that place and type are actually two variables in the data set, but location is only one. The way this data set stores information, those two will actually get merged. If that doesn't happen, what I do recommend doing, because every so often this USGS data set gets entered with some slightly weird formatting, if that doesn't happen correctly, I recommend taking out the location variable entirely and taking out place and type. Normally this will do things like attach Arizona to Phoenix, so place being Phoenix, type being Arizona. Sometimes it doesn't work that way, so just feel free to take those out if it's working improperly. Okay, we're going to talk a little bit about Story Builder. There will be a quick guide in student handouts for them to use, and I think that'll be for sort of their work on the final project. The idea of this is that students can, as they go through an exploration, record their steps along the way. So every time they do a new analysis, they could record that as a step of their overall process. We'll walk students how to do this, but be aware there's an example linked on this page that'll bring them to a CODAP dataset that shows this. And yeah, we'll have them try to practice this today, and we recommend that they use it again in the final project. Okay, so what we want to happen is students to copy the output, open CODAP, select a new document, go to tables, and select new from clipboard. This should paste in all the stuff from today. The new piece is that we want them to go in and start in the plugins menu, storytelling, story builder. And this will allow them to save those different stages of their analysis, like I just described in this multi-slide story. Okay, so by doing this, students have created their first moment. They should name the moment in the title box. They might name this Introduction to the Earthquake Dataset, or just like Exploring Earthquakes or something like that. They can look over the data and create any graphs they want. They should take some notes in the description box and save this moment by pressing the check button. Anytime we create a new moment, we should save it once we're ready by clicking the check button. So what we'll do now is click the plus button to create a new moment, and we'll call this magnitude. We're going to create a graph with just magnitude on the y-axis, nothing else here. Remember, and you might want to remind students, this is actually pretty interesting, that magnitude is a number on the Richter scale. So each increase of 1 is really an increase of 10 times the magnitude. So for example, an earthquake that is a 3.0 is 10 times stronger, not just a little bit stronger, than an earthquake that is a 2.0. Many earthquakes are below a 4. So if students are seeing things that are like 5s, 6s, 7s, those are actually a pretty big deal. So our next analysis is going to be, does depth predict magnitude? We're going to use the ruler icon to show the mean and the standard deviation of the graph. In the notes of this moment, we want students to record the mean, standard deviation, and variance. The variance is going to be the standard deviation squared. Students will have to do a little math for that. It'll really pay off if you do these extra slides later on. If students happen to skip the variance, it's not the end of the world. At this point, they should save this moment using the check button and create a new one. This moment they should call magnitude and depth. And here, we're going to create a scatter plot to look at a relationship. Now, student graphs might look, and almost certainly will look, different because they'll be looking at a different day than I did. But they're going to put magnitude again on the y-axis, but now depth on the x-axis. So what we're doing is predicting the magnitude of an earthquake from that earthquake's depth. In the note on this moment, we want students to describe the association. What's the direction? What's the form? What's the strength? And do you see any outliers? Again, this is going to vary by graph. It might even vary student to student if they don't all download the data set at the same minute. So this is like pretty real data, very in a sense, very authentic analysis because they're each getting their own data set to mess around with. Okay, we're now going to have students create another new moment and call it the relationship between depth and magnitude. On the same graph that they just created, so they don't need to make a new one, they can use the ruler icon and add a least squares line to the graph, as shown. They should, in the notes, write down the parameters, and you see a model for this here. The slope is blank, in this case, negative 0.019. What does that mean? Well, I think it means that as depth increases, magnitude actually goes down a little bit over time. Interesting. We can also interpret the intercept. The intercept is 3.83. I think this means that for an earthquake that's at the surface, right, no depth, we're expecting a magnitude of 3.83. I don't know if that makes sense. I don't know enough about earthquakes to see if that's nonsense or not, but students might want to think that through and say, does that make sense? Then we're going to have them do a prediction. What magnitude would you predict for a depth of 40 miles? This is just plugging in that value of 40 and seeing what the output is in their equation. So The next thing we want to look at is r-squared. The r-squared value presented along with the line of best fit tells us how much variability in the y variable, in this case magnitude, is explained by the x variable, in this case depth. R-squared has a range from 0, which means our model is pretty terrible, all the way up to 1, which means our model is amazing and is explaining all the variability in magnitude. Feels unlikely, usually is. So what we're looking at is a lot of variability in magnitude explained by depth in our model, or just a little bit? So to give you some example numbers here, if I got, say, a 0.2 for r-squared, actually here I have a 0.03. So that means that not very much of my magnitude is explained by depth. If that number was instead something like 0.8, like 80%, then I would say, wow, quite a lot of the variation in magnitude is explained by depth. As I keep moving, we want students to think about interpreting this graph overall. This is sort of an amalgamation slide. Students have done a lot of different work on this, right? They've found a line of best fit, they've looked at the direction, form, strength of that, they've looked at the r-squared value, they've interpreted the coefficients. Now is time to sort of put all this back together and think about the most important features of this graph. What I'm looking at right now, I would say, is just a not very strong relationship between depth and magnitude. So students probably would want to emphasize that like this really isn't that much of a relationship here. Earthquakes can kind of seem to be whatever magnitude they want regardless of depth, and that might be a really important takeaway. So we're going to do this as well, just to look for some confidence bands, kind of building off what we did last time. We're going to go back to the ruler icon and select Show Fit Uncertainty. This will add confidence bands to our least squares line. If we think about this model as a tool to predict magnitude from depth, these confidence bands are helping show us the variability in our different predictions, right? For example, the line itself probably is giving us a prediction value, but the confidence bands are showing us how much that prediction value probably might be wrong by. Again, we want students at this point to save this moment and save their interpretations, which should at this point be in the notes. Okay, now we want to look a little bit about how wrong our predictions are. So we're going to create a new moment. We're going to call this predictions. Students are going to need to create 2 new attributes in the original data table. This is something we might expect them to do on the final project if they feel like there's a new variable that they need to add. So please make sure that they feel pretty comfortable doing this. They're going to go to the top right of the table, click the plus button, and add a new attribute. They can call it predictions. They're going to click on the name of that attribute and go to Edit Formula. In the Edit Formula menu, we're going to have them type in this weird little function, lin regression predicted, which is it's a linear regression prediction function. And basically what it does is predicts magnitude from depth based on our linear model. So this is going to fill the whole column, and you'll see this happen automatically, with predicted values for magnitude based on our line of best fit. Students can now compare these values to the actual values of magnitude. If students need another function, there's a whole bunch of them tucked into this insert function menu. They may want that for the final project. Maybe good to note here, we don't need to use any other functions today, except for this little one. So we're going to create another attribute. We're going to call this one residuals. In the Edit Formula menu, we're going to type in magnitude minus predictions. This is a simple difference between our actual magnitude data and our predicted magnitude data. And what this should do is give us a whole bunch of residuals. For your explanations, you can think of a positive residual as actual data that comes out above the line of best fit. A negative residual, on the other hand, would be actual data that falls below the line of best fit. Sometimes students get a little bit confused about actual data, right, which are the data points, versus our predictions, which fall on the line of best fit. It's a really good opportunity with this lesson to emphasize that difference and make sure students know that the line is just predictions. It's theoretical, like guesses as to where the values are going to come out based on our actual data, but the line is not actual data itself. Okay, so we're going to save this moment in Story Builder. This should have any notes on the two attributes, predictions and residuals, that they just created. This is a great time for students to write down what predictions really mean, what residuals really mean, in case they want to make sense of that later. Optionally, there's 2 more slides coming up. You could use these slides to learn a little more about these 2 parameters. There's some information about residuals. There's also some information tying that concept back to the variance number that we found way earlier in the lesson. Consider doing these if you have time, particularly if this is a stats class or a class that has any kind of statistical background. If they don't, this variance concept might be a little bit like new and strange for them. If they do, on the other hand, they'll probably click with this very well. Our exit ticket today. We want students to submit a link to their CODAP program, and we want them to list one interpretation that they can take away from one of the graphs they created. We've given them a couple ideas here. We're trying to build them towards the final project. So we're thinking about relationships, variability, and potentially unusual cases. With the graph that I had today, I might say, you know what, there wasn't that much of a relationship between these 2 variables that I thought there might be, which is potentially a less interesting story, but also kind of answers this question for me of, is there a relationship between depth and magnitude? Thanks for watching this video, and as always, thank you for teaching the API CAN Code curriculum.